application is handled by operating system. You will not realize that more number of applications simultaneously can be handled by operating system. That abstraction the operating system provides to applications. Okay, so you will not find out the complexity. Okay, so more operating systems gives some abstraction like processors, address space, files to the users. Okay. Now we will see what is process, what is address space, why files are difficult to handle by the operating system and all. Simply what is process, when you start any task in your computer, in your desktop or laptop, a new process will be created. Not only you have to start only manually through user, the process will be started. There are many processes which are default, which are background processes. Now, when you start your mobile phone, there are many applications automatically started even if you go and start. If you did not go and start also, it will be started. Those are automatically on the background. Okay, like that in the general computing system like laptop and desktop also, when you start, there are many processes which are commonly called daemons and background processes that will be automatically started. You will not realize that those programs are started automatically. Okay. When you press Alt Control Delete, you may see there are many processes. Okay, you may wonder, okay, these are the processes I did not open. I open only the browser, but how these are the processes it is showing. Okay, but those are automatically what background processes. Okay. So a key concept in all the operating system is process. Process is basically program in execution. Program in execution is called process. There are many programs, but all the programs will not be executed all the time. Okay, some program only will be executed. For example, you are starting a Word application, so the software to execute the Word application will be automatically started, so that program will be executed. Okay, so program which is currently on execution is called process. Remember. Okay, what is process? Program currently on execution. Process program currently on execution is called process. Okay. When when a program is getting executed, that means now I can no need to say that. Now you know, no, when I'm saying process, you know, process is currently executing program. Okay. So when I'm saying program is started, program is created. For example, when you start the Word application, one program will be executed. So there is a process created. Okay. So when the process is getting created, simultaneously process ID will also be created. Okay. So assume that currently there are 4 processes on execution. It is not necessary at a time only one process will be in execution. It could be in more than one number of process also, because nowadays our CPUs are multi-processing system. Okay, so multiple processes can be executed at the same time. So in a multi-processing system, whenever a process is getting executed, for example, there are 4 applications now currently you started. Okay, so 4 processes started. Okay, 4 process all the 4 process will have unique ID, which is called the process ID. The process will not be identified using its name. Okay, it will be uniquely identified by using its process ID, which is simply called PID. For example, if you take in Linux and all, it will create process ID like 1001, 1002, 1003. Like that, it will give the process ID. Okay. that process ID will be identified by the variable PID. Okay. So when anybody asks what is the PID of this word processor which you open currently, that will show the process ID. Each and every process will have unique process ID. For example, currently in one multiprocessing system, there are 4 processes started. All the 4 processes will have different ID, will not be repeated. That's why I'm saying unique. Okay. How in your classroom your roll number is unique? Roll number 1 may there will not be no more than 1 students, right? So that roll number is uniquely identified. Whereas when we consider your name, okay, there are more than one number of Akhilesh can be there in one class. Okay. So we can't keep the name as what? Unique ID. We can keep roll number as a unique ID because that will not be repeated for more than one number of students in a same class. Okay. Like that, in a multiprocessing system, when the process is getting created itself, automatically operating system will assign process ID. Ria, little slow, Ria. Okay. So when the process ID will be created, along with that, address space for that process will also be created. Address space, Ria. Address space for that process will also be created. What is address space? You know, process is a program on execution. Okay. When any program on execution that needs some memory, because program may some variables would be there, temporary variables, global variables, some data structures need to be stored. So some memory it needs. Okay. So that memory individually for each and every process will be allocated by operating system. That memory for every process is called address space. Okay. What is the individual independent memory for every process? That should be called address space. So address space is also one address space will not be shared by more than one number of processes. Remember, address space is individual, independent for each and every process which are there currently on execution. Okay. See, when we are talking about the operating system will manage only the active processes. If you open your computer, there are 1,000 number of applications could be there, but all the application you will not, now it will not be a process. You will not be started. Only whichever applications, for example, 3-4 applications only at a time you will start. So now wherever we will consider only those active processes, active applications. Okay. Other applications which are not enabled currently, we are not going to bother only, because when 4 applications or 4 processes are created, only those processes need to share the main memory, input output devices, some database tables. So the only active processes will share all these resources. Okay. So wherever more than one number of processes sharing something, there only the issue will come. There only we need some interface like operating system to manage or to synchronize, to handle in optimal way. Yes.
Ma'am, currently you are at slide number 21, na?
Yes, slide number 21.
Okay.
Yes.
Okay.
See, in the PPT, I did not put any content, only the heading. I am talking about processes now. Okay.
Yes, ma'am. I thought your screen closed, so I asked.
No. I'm showing only this heading. And inside that, I'm explaining, you just note down what are the points will come in processes shortly.
Okay, ma'am.
Okay. So in a multi-processing or multi-programming system only, always the problem. Why in a uniprocessor system, only one process, suppose that only one application you can open at a time. No problem at all. You will open one process. There is no need of operating system because that one process aram se it will use the entire main memory. So we no need to share the main memory. So only that process will use IO, whichever input output device it wants. Okay, whichever file system it wants. After that process completed the task, next process will be created. So like this, in a uniprocessor system, there is no issue. There is actually no need of operating system at all. Whenever more than one number of processes on execution, that time only problem will come. So we need an interface called the operating system. Okay. Okay. So what we saw under the processes, what is process? Program on execution. A program on execution is called a process. Okay. What is process ID? Whenever a new process is created, operating system will assign a unique ID for that process. That is called a process ID. What is address space? Whenever a process, new process is created, operating system will allocate some address space, some memory. Okay, which the process can use during the execution. Okay, so that is called the address space. Okay, now this address space can be for every process. The address space location could be from 0 to some maximum number. For example, 0th address space and address space. In address space, there are many addresses. Okay, some range of addresses would be there. For example, 1000 to 1100. Here, 1000, 1000 and hundreds are what? Binary numbers. Okay, don't think that is decimal. Okay, so 10002 to 1100. Many addresses in a single address space. When you ask, ma'am, every process ka address space will be same size? No. Every process, the size of the process is different. Some processes are complex, some processes are very simple. Then the same address space will not be allocated. Okay. So every process will have some range of addresses. Process 1 may have 0 to 100. Process 2 may have some other range. Okay. So that is different. So that is called address space. Okay, so what is process? Process is fundamentally a container that holds all the information needed to run that particular program. Okay, process is fundamentally a container. So process will have everything. Process will have its own process ID, identification. Process will have its own memory. Process will have its own resources. There are some resources, private resources, some are public resources, shareable resources. So like that, a process is fundamentally a container that holds all the information which are required to run that particular process or that particular program. So program will be created and then it will be used and then it will be deleted. So starting from creation till the deletion, whatever the process requires, everything will be there with the process. So process is a container. Okay. How can you understand the process? For example, today, now you are opening your laptop. Okay. You want to, you are doing on video editing. Okay. There is a video editing program. Using that is a 1 hour program, that video. You are converting that video into a particular format. Okay, so video file to some other extension. Okay, some other video extension. So streaming, you're doing video streaming, that will take 1 hour that you started. Okay, now it is going on. When it is going on itself, the streaming, video streaming is going on. That time what you're doing, you open the web browser and you are searching something. Okay, some information you want to know, you're searching that. Now in one side your video streaming is going on. Okay, so that will take 1 hour. And then in the same system you are surfing next web, you are searching something and you're reading something in the web. In the meanwhile, what is happening in the same system, in the background, if any your email server also started, that means if any email comes, the notification will come in your notification area of the system. So that program also background made is working. Okay. So how many applications now? How many processes now? 3 processes. Okay. So what are those 3 processes? Video editor is working, and the web browser you're surfing, and email receiver it is waking up. It woke up because it monitors. It started to work. Then only any point of time when you receive email or Gmail in the Gmail server, it will immediately send the notification. So that should also be activated, executed the whole time. But that is a background process. It will be activated. It will send the notification once you received the mail periodically. So there are 3 applications it is on execution. Okay. Now these 3 application need some memory, because when you edit the video, when you do the video streaming, one particular slack of video will be stored, and then the next will be started to stream, and then that will be stored. So we need a memory and other devices. Okay. So now each applications need its own resources and memory. Okay. So now all these, who will handle? Okay, this is the address space for this first process. This is the address space for the second process. Who will allocate this? Our operating system. Operating system one will only allocate the address space, or whatever requirement. What are the requirements for the process? Okay. Now you understand clearly what is process. Remember, one process can create other process also. Okay. One parent process can create other child processes also. That means in one application, you can what you can do, you can type and save the program, and then in another tab you can watch something also in single application. Okay. For example, you are opening a browser mein one tab mein you are watching video. Okay. In another tab you are reading some book. Okay. Or in one tab you are playing some audio, something like that. So here application is single, but there are many tasks. So parent process is the process which will invoke the opening of the application, and after once you opened whatever you are doing, that will be a child process for that application. So there is a parent process, and under that there are many child processes. That is also possible. Okay. So when parent process created, now see this here, there is a parent and a child. And this is this parent child creation of the processes create a tree structure. See, A is a parent. Okay. B and C are child processes for parent A. And then B created 3 more processes. Okay. Now D, E, F are children for what? B, process B. So now B is a parent for these three children. Okay. So like this, the parent-child creation of the process may create the tree structure also. So why then this is important? Suppose you have created process A, okay, and then some other task you enabled within that created B and C, and then under particular tab may you did is you enabled some other task, so that created three more processes. Okay, now if you want to delete process A, what you have to do, you cannot directly delete process A. You have to first delete these three processes, and then process B will be deleted, and then C will be deleted, and then only you can delete A. So that is a problem with, not problem, that is little difficult with the parent tree structured processes. This is a single process. When you consider this as there is a single application involves, but there are number of processes or more. Okay. So when you create a system call, where this process will be, all these process will be handled by operating system. Okay. So when you want to create or you want to delete a particular process, you will create system call. Okay. So the system call will first, you will give a command to create. You will right click this and you will delete this. Okay. But internally what will happen, directly this will not be deleted. Okay. First, that main system call which you created to delete this particular uh, process will create another system call to create these three processes. After deleting these three processes, there will be another system call will be created to delete process B. After deleting to delete process B, so after deleting process B, another system call will be created automatically to delete process C, and then only process A will be deleted. Okay. Or otherwise, you are doing some editing in process E, child process E. Okay. How can you edit this? So first you have to come to open the process A, you have to create open a system call, and then that system call should open B. It will not open C because C does not have any relationship with what? E. So B will be opened, and then you can go E and you can edit. Okay. So that you have to remember. There are chain of system call order will be created to do the hardware related function related to process. Okay, so the process could be like this also. We are discussing about the basic concepts of operating system. Okay, inside that we discuss about the processes. Okay, inside the process, what and all we see, what is process. Okay, how the process will be created. Okay, what is process ID, what is address space. Is all the address spaces or all the address spaces are in equal size? No, that we understand. Where this address space will be created? Of course, initially that will be in main memory, but there is a variation. Sometimes I did not say anything about the virtual memory. We will see that. Okay. Even address space can be created in virtual memory also. That is not, now it is not, don't confuse with that. Okay. And then we discuss about the parent process, child process. So we can call that as a process tree. Okay. So if you want to delete one particular innermost child process, then the parent process, you have to first delete the inner process. That means the child process of that process which you want to delete should be deleted first, and then only you can delete the main process. So all these we discussed. Okay. And next, address space. Of course, address space, I said, we saw actually what is address space. Each and every process will have its own memory, which can be used during the execution of the process. So that is called address space. Every computer has some main memory. Okay. That main memory is used to hold the executing programs. So what is the use of main memory? Main memory will be used only to store the temporary memory about the process which are on execution. Okay. Of course, when we are saying process, it is the on execution. The task on execution will automatically understood. Okay. So every computer has main memory. That main memory is shareable memory. Okay, only one process will not always use the main memory. There are multi-processing system, there are multiple processes. All the processes should be able to share the main memory. Okay, so that is going to hold the executing programs. Main memory is going to store the information about the on executing. That means process. In a very simple operating system, if you consider, only one program can be executed at a time. Okay, assume. Okay, so that one program will utilize the entire memory space. Okay, so there is no need of memory management by the operating system is required here. Okay, very advanced, sophisticated operating systems allow multiple programs. Nowadays, all the systems will allow multiple multi processing. Okay, so when multi processing is there, memory should be shared. Okay, so in a multi processing system, the memory will be shared among the multiple processes. Okay, assume that now currently there are 10 processes. All the 10 processes ka address space would be there in a main memory. Suppose the main memory is not sufficient for currently executing process. What will happen? Suppose all the 10 processes are now on execution. So all the 10 processes need some range of memory. So that is more than the requirement of the main memory of all these 10 programs, or more than what the available size of the main memory. Then what will happen? Then only, because of this only, there is another concept called virtual memory. Virtually, now how virtually you are attending the class. These are not physical classes. Directly, I am not teaching to you by seeing you, and you are also not looking at me to listen the lecture. But virtually, you are attending the lecture. Virtually, I am taking the lecture. Okay. Like that, virtually there is a memory. Why? Because our always main memory is a storage constraint, no, very less storage. Main memory has less storage. But in multi-processing system, there are more number of processes. Okay. So all the processes are getting executed. Then of course, all the processes need some addresses, which are called address spaces. So what then on because of this only the virtual memory concept got invented. Now virtual memory is actually not the part of the main memory. Okay, because already we don't have the sufficient main memory. That's why virtual memory. No. So virtual memory is a memory which will be there in a secondary storage. That means your hard disk. Hard disk may one part will be allocated to create a address space. Okay. For example, there are 10 programs, 10 address spaces. First half of the address space of all the programs will be there in the main memory. second half, for example, okay, second half of all the programs address space will be there in the virtual memory, which is nothing but our hard disk. Okay. So if you look at every process address space, it's half of the address space will be there in main memory, remaining half will be in the hard disk, that is virtual memory. Okay. You may wonder, ma'am, then everything you can keep in hard disk, no? That though enough space is there. No. What is the advantage of main memory? It is very speedest memory, very fast memory. Okay. So on execution program should be executed very fastly by the CPU. Okay. So now how then the process will use half of the memory in main memory and half of the memory space in the secondary memory? There is a concept called swapping the data in the memory. Okay. Assume that a program has some data. Half of the data is there in the main memory. So anytime it can pick up, the processor can quickly pick up the main memory data and it can execute. Assume that there is a system call that require a particular memory. For example, process A ka execution got over. Now for the next execution of the process A, it needs some data from its virtual memory, virtual address space. What will happen? That particular required data from the virtual address space of that process, no, that will bring to main memory and put it in the address space of the main memory of that process, and some other process which is some other data which is already residing in the same address space in the main memory will be take out and kept inside that virtual memory of that address space. I don't know, can you follow or not? Students, if you couldn't follow, please let me know. Could you follow what I'm saying? Students, could you follow what I'm saying? I'm just explaining the virtual memory. Why we want virtual memory? Because there is no sufficient space in the main memory. Okay. Okay, why you can't use only the main memory even if it is not sufficient? Because in a multi-processing system nowadays, very advanced processors, which will support more number of processes at a time. So of course, for every process, we need to give what? Operating system need to give memory. Okay. So to satisfy all the process, half of the address space of each memory will be there in the main memory. Remaining half of the address space will be there in the secondary memory, which is nothing but a hard disk. Okay. So then how a process will use the data from main memory and secondary memory? Through swapping. Whenever any data which is there in the address space of virtual memory is needed, it's that process main memory address space is already filled, no? Okay. So newly anything it has to bring from the virtual memory address space to main memory address space. From the main memory something should be removed. Okay. So then applying the algorithm, any one of that is called the page replacement algorithm that will be implemented by the operating system only. By following any one of the page replacement algorithm, already existing data in the main memory address space will be removed and it will be kept inside the secondary memory, virtual memory. Now we will get a free slot in the main memory, no? So there the data which is going to be executed, which we just now we bring from the virtual memory, can be stored in the main memory. Sorry?
Excuse me, ma'am, can
What?
we take our 15 minutes break before the
Yeah,
next
it is going
lecture?
because these concepts are going very what? You can't continuously listen. Okay. So, okay, now 37 हो गया. Chalo.
Ma'am, but why do we need swapping? I didn't understand.
Why we want swapping? See, there is a program. Assume that in simple way that program is on execution. Okay. So that program has 10 addresses to store the 10 small addresses means you will confuse. Small cell in a memory. Okay. To overall start its execution and till completing execution, 10 small memory cells it want, assume. Okay. But only that program is not there now currently on execution. There are so many other programs also. Okay. So for this program, which needs 10 cells, memory cells, operating system cannot allocate all the 10 cells in the main memory because it has to allocate main memory for other processes also. No. So what it will do, operating system will do, only 5 cells it will allocate it in main memory. Remaining 5 it will allocate in a secondary memory. Okay. So एक process का 5 cells का data will be there in a main memory. Remaining 5 cells data will be there in the virtual memory. Okay.
Oh, yes, ma'am.
Supreet, what happened? Supreet?
Yes, ma'am.
What are you doing? Why the animated emojis? Huh?
मैम जस्ट ऐसा क्लिक कर रहा था, मैम ट्राई कर रहा था कुछ नहीं।
Sorry?
मैम जस्ट ट्राई कर रहा था, मैम इसके मतलब देख के
What are you trying?
वो फीचर आया था ना, इसलिए देख रहा था।
No, something you want to say, that's why you're saying through the emojis or what?
No, ma'am. If
Then
ma'am,
during the lecture, why are you displaying those images?
no, ma'am. If I had to, ma'am, मैं ऐसा पता चलता, ma'am. How can I?
If you want to?
मैम नहीं मैम, ऐसा नहीं करता, मैं ऐसा बोलना चाहता हूँ, ऐसा नहीं करता रहता।
But during the lecture, you no need to try all those things, no?
Yes, ma'am. मैम लेक्चर एंड हो गया था, तो ऐसे मतलब ट्राई करता देख।
Okay. So half of the 5 cells will be in the main memory, 5 cells will be in the virtual memory, which is nothing but virtual memory is a portion of the secondary memory. Okay. So during on execution, some data can be required by the CPU from the virtual memory also, no? So operating system will do swapping. Swapping is nothing but from the main, that 5 cells which are there in the main memory, no? In that one cell will be removed, one cell data will be removed and it will be kept inside the secondary memory. And from the secondary memory, which data is required to execute currently, that will be stored in the one of the cells of the main memory. Okay. Now, whichever data is currently needed, that will be there in the main memory. That will be bring from the secondary memory to main memory. Okay. So this is called swapping. Through swapping, it will manage to execute the process. Whenever any data which is stored in the virtual memory is required, it will just bring to anyway the data should come to main memory. Directly from the secondary memory, it cannot, CPU cannot fetch the data. Okay. But through swapping, some old data will go to the secondary memory address space, and that which data is required currently to execute, that will come to main memory. Okay. This is because of main memory is having low memory space, and also nowadays we are using the advanced processor which can support more number of processes at a time. Okay. Because of these two reasons only, we have a concept of virtual memory. Is this clear, Sahu, Kajal?
Yes, ma'am.
Okay. So students, thank you. You all can leave. The
Bye, ma'am.
PTM will be PTM. The students, those who are under me, no. PTM will be conducted tomorrow, mostly 3:30 onwards. I will confirm with the NSM ma'am also. Okay. So tomorrow 3:30, 90 percentage my meeting, PTM meeting will be there, because why I'm saying you have to inform to your parents. No. Okay. So 3:30 or 3 o'clock. No. What is the timing of practical? 3:30. Yes, 3:30. I will start the PTM. Okay. Somebody came to ask something. What is that? Students, you want to ask something? Students? No. Okay.
No, ma'am.
Okay. Thank you, students. You all can leave.
Bye, ma'am. Thank you, ma'am.
Thank you, ma'am.
Bye. Bye. Thank you.